Hi everyone! Today we're going to talk about how to calculate combinations of two functions and then define the domain of those combinations. To complete this problem, we'll calculate our combinations, simplify, and then define the domain of each. Let's take a look. In this particular problem, we've been given the two functions f of x equals x cubed plus 2x squared and g of x equals 3x squared minus 1, and asked to find the following four functions and their domains. So as you can see, we're going to be finding f plus g, f minus g, f times g, and f divided by g. And we're just talking here about combinations of functions. These are different combinations of f and g. The first one is obviously just the sum of the functions, the difference of the functions, the multiplication and the division of the functions, or the product and the quotient of the functions. So let's go ahead and start with f plus g of x. And this is going to be really simple. When we add functions together like this to find a combination of these functions, we'll just add f and g together. So f here is x cubed plus 2x squared, and g of x is 3x squared minus 1, so we'll add 3x squared minus 1. And now we just need to simplify that. As you can see, we'll get x cubed. When we add 2x squared and 3x squared together, we'll get 5x squared. And then, of course, our negative 1. And that's it. That's really as far as we can simplify. We've also been asked to give the domain of each of these combinations of functions, so we'll go ahead and do that. And we'll say that the domain here, the domain is equal to, the domain of any polynomial function like this is all real numbers. So we can just denote that with all real numbers like that. As far as the difference of the two functions, really similar, we have f minus g of x here, so we'll just take f, which is x cubed plus 2x squared, and we'll subtract g of x. Don't forget to put g of x in parentheses like that so that you make sure you distribute the negative sign. So when we subtract here, we'll get x cubed. 2x squared minus 3x squared will give us a negative x squared. And then we have minus a negative 1, which will give us a plus 1. Again, we've really simplified as much as we can, so now we just need to indicate the domain. And in this case, again, we have a polynomial function, so the domain is all real numbers. If we look here at the product of these two functions, f times g of x, similar concept, we'll just be multiplying the two together, so x cubed plus 2x squared, and then multiply that by g of x, which is 3x squared minus 1. So now we'll be expanding these with our FOIL method, so we'll have x cubed times 3x squared, which will give us 3x to the fifth. X cubed times a negative 1 will give us negative x cubed. 2x squared times 3x squared will give us plus 6x to the fourth. And 2x squared times a negative 1 will give us a negative 2x squared. So now when we reorder our terms, we'll get 3x to the fifth plus 6x to the fourth minus x cubed minus 2x squared. And again, we have a polynomial, which means that our domain is all real numbers. Finally, our last function here, the quotient of f and g, we'll take f of x and we'll divide it by g of x. So we'll see that our numerator here will be f of x, which is x cubed plus 2x squared. And we'll divide that by g of x, which we know to be 3x squared minus 1. And there's really not a whole lot we can do here to simplify. We could factor out an x squared from our numerator, but that wouldn't allow us to cancel anything. So this will be our quotient function. We just need to figure out what the domain is. And remember that the domain of a rational function like this, a rational function being the quotient of two polynomials, a polynomial in the numerator and a polynomial in the denominator, is undefined wherever the denominator is equal to 0. So the domain is going to be all real numbers except where the denominator equals 0. So we need to figure out where that is the case. So we'll say over here 3x squared minus 1 equal to 0, and we need to solve this to figure out which part of our domain is undefined. So we'll add 1 to both sides to get 3x squared equals 1. Divide both sides by 3 to get x squared equals 1/3. And then we want to take the square root of both sides to solve for x. So we'll get x equals the square root of 1/3. So we'll say the square root of 1/3. And remember that when we're taking the square root of a fraction like this, of a quotient, we can take the square root of the numerator and the denominator separately. So we'll get x equals the square root of 1 over the square root of 3. We know that the square root of 1 is just 1, and then we have the square root of 3 here in the denominator. But remember, we have to include a positive or negative because we could get positive 1 over the square root of 3 or negative 1 over the square root of 3. Both of those would make our denominator equal to 0 and therefore our quotient undefined. So we can say that the domain of this function is equal to all real numbers except x equals positive or negative 1 over the square root of 3. So we can just say the domain is x not equal to positive or negative 1 over root 3. And that indicates that x can be any value except these two and defines our domain. And that's it. That's how you find the combinations of functions and their domains. So I hope you found that video helpful. If you did, like this video down below and subscribe to be notified of future videos.